Let me show you the beauty of what we've done. I have my square corner bracket. I have a couple side supports here, and I'm going to go ahead and just slip a board like I was going to CNC it. I'm going to press it forward, and then I know that this edge is flush, so it's parallel to my router. And then I push this way, and I know it's aligned that way. And then to hold it in place, I could use the T-tracks, but I'm going to use something else. I made these little cams. This is a larger diameter one back here. This is a smaller diameter. My next video, I'm going to give you the free software that you can just cut and paste from right below my description of my video into OpenSCAD, and you can make whatever size diameter cam you want, whatever handle length you want, where the pivot point, wherever you want, and then you can cut them out on a scroll saw, a bandsaw, a router, your CNC. When you get all done, you're going to put threaded inserts into your table, and then once you have those threaded inserts in, you can pivot this. If it's too far away, your threaded insert, so it's not actually hitting the board, you just put a shim board in and press, and it will push pressure. And here's another cam I've got on this other side, and I'm just going to put a little shim in, and I'm going to press. And when I'm done, you can see it's got a nice hold. I could put another hold down over here if I wanted to, but that does a really nice job. The beauty is when you get all done, you just release the cam, you pull out this, and you're ready for your next board to go on. You didn't drill any holes, you didn't waste anything.
I'm in Vcarve Pro, but you can use this in Vcarve Aspire or Vcarve Desktop. I'm going to show you how to set up braces that you can mount on top of your Spoilboard to help hold boards square to your surface, so you don't have to perfectly align them to the grid lines, but to have something to push against. With that being said, go ahead and put in the board dimensions that you're going to be cutting your braces out of. This is what I put on my particular CNC, but you can use smaller boards than this. Measure the thickness of your board, put it in here, put the datum in the bottom left-hand corner, click OK. Then we're going to take advantage of the grid snapping. So go to the grid snapping tool, top of the Vcarve software, click on it. Some dots should appear. If they don't, go ahead and click F4 and click on snap to grid. I like them every 20 millimeters and click OK. That allows me an easy spot to reference off of. Then I'm going to create an L bracket and a couple horizontal brackets on here that we could do profile tool paths on to create our braces. With that being said, let's go ahead and do the corner brace using the polyline tool. Click on it. I'm going to start in one dot to the right and up, and I'm going to trace an L pattern going 40 across and creating a structure something like this. You can make it however big you want it. I'm going to click close. There's our L bracket. This would be a problem if we came with a CNC bit, because it's a round bit. It's not going to be able to get this corner perfectly, and we want this edge and this edge to stay perfectly straight. So we need to cut a little pocket so that we can push a board this way and down and not have it run into the corner that is not correct. To do that, we're going to go ahead and click on a circle, and we're going to put in a diameter of a circle of 25 millimeters. Click on that corner. When you do, then we're going to go down to Edit Objects. We're going to find the little scissors, which is an interactive trim tool. Click on it, and we're going to cut out some of these lines. Now we have a nice corner spot to put a board against. We can make this even nicer. Let's go ahead and utilize another feature that's inside Vcarve. Under Edit, you should have something that says Fillets. Change the tool radius to 6 millimeters. That's a nice corner. And everywhere there's a corner, we're just going to click on it, and that will smooth everything off nicely. So we get good, clean lines when this machines, and we're not going to run our hand into it and scrape ourselves up in the future. At this point, we could go create a profile tool path, but I'm going to stop there for the moment, and let's go make a couple other ones. I'm going to use a different method now. I'm going to just use a rectangle tool, and I want a nice horizontal rectangle that I can use to mount, and I want it 40 high and 220 wide, and I'm just going to click on here. The starting point will be on the bottom left-hand side, so I'm going to click it maybe down here, and there we go. Let's go ahead and fillet off those corners. So I'm going to come in here and I'm going to put some fillets. And let's make another smaller brace. Let's go and click on the draw rectangle tool. And let's say this is 160. Let's make a little pieces that we can mount on our CNC machine. You can make these however, whatever size you want. And I want to just go ahead and put it up here and click on it. Let's go ahead and fill it off those corners. We're still using a 6mm fillet. Like so. If this is your first CNC, we could just profile toolpath this off, hold down my left mouse button, keeping it pressed, and dragging a box across to encapsulate all those vectors. Now they're all selected, they've lit up in red. Go over to my toolpath tab, click on the thumbtack so that it holds it in place. Under toolpath, go click Profile Toolpath for the start depth 0, for the cut depth, whatever your board thickness is that you're cutting your pieces out of. In my case, my plywood was 12.1 millimeters thick. I'm going to select my tool. I want a downcut bit so that it makes the top edge of my plywood as nice as possible. So this is a 1/4 inch downcut end mill. I want to cut outside the lines. So by doing that, my bit will come around and the far edge will be on the outside. That means this distance here will stay the full 40 millimeters, which is ideal since my grid lines were that way when I screw this down into my main spoil board, I can just line it perfectly over those grid lines and I know that I'm perfectly parallel. Then I need to add in tabs. If I were to cut this as is, when I do my final pass, one of these pieces come rattling loose and potentially fly back at me or damage the surface more likely. With that being said, I'm going to put in enough tabs that I think is going to hold it secure. Put as many as you think are necessary. And here's what I'm using for my tabs. I don't really want to put tabs here, 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 and here because I want this edge to maintain as pristine a condition as possible. Same thing here, I'm going to call this my good edge that I'm going to be mounting boards against. So I'm going to put my tabs on the other side of here, and to put a tab in, you just need to hit the edit tab button and just click wherever you want the tabs. I'm going to put about 3 on each side around each of these structures like so. And I want 1 on each end. And when I get all done, I'm going to cut these tabs and sand them off anyway. But I still don't really want to have anything marring up my good edge. Something like that's great. And let's change the name of this. We can just call this Profile CNC Edge Guides, 1/4 bit, depth of cut 12.1. Calculate. Let's see what this is going to look like. So I'm going to reset my preview and preview visible toolpaths. And there we go. And you can see those tabs would hold it in place. And then we could go cut them out. Place this over the grid lines that we already have cut into our spoil board. Screw it down. This would be in the corner. These would be, you know, 1 out here and maybe 1 up here, rotated. And you could make that work. I'm going to go into my 2D view over here, and I'm going to put in some insets for some bolt heads, and I'm also going to put in some 1/4 inch bolt holes for different positions that are evenly spaced across each of these. So let's do that, and it's handy for selection purpose to add a new layer. So I'm adding a new layer, and I'm going to say this is bolt head insets, and I'm going to go 12.5 millimeters diameter. So let's do that, and then you can decide where you want to put the bolt heads. Those bolt heads are going to have threaded inserts underneath that we can go into. So you want to be thinking about where a position is on the board below your in your spoil board that you can actually have spots for threaded inserts. You don't need them in all these spots, but it's better to actually cut the positions here, even if you don't end up putting threaded inserts into all the positions on your actual spoil board. I think it'll make more sense when you actually see it done. So let's go ahead and do this now. And I'm going to click on the circle. I want the radius, excuse me, the diameter of this to be the diameter just slightly bigger than my bolt head. I'm going to use 12.5 millimeters, and I'm going to click it in positions that I think would be a good spot. So I'm going to start the first one. I'm going to start the first one at 80, and then I'm going to do, excuse me, this one was 100. I'm going to do at 140. I'm going to do at 180, and I'm going to do at 220. Then I'm going to come across here, and I'm going to do one at 80, and I'm going to do it every 40 beyond that, all the way out for everything that'll fit. I'm going to do a similar strategy for these other pieces. So I'm going to just go fill in along the way, and you can decide where you want to put your bolt holes. Oops, I don't like the middle one there. I would like it like that. So it's nice and evenly spaced. That makes it easier to put your threaded inserts below. That looks great. And let's go ahead and do another layer. Add a new layer. And this will be bolt 6.4 millimeter hole. With that being selected, I'm going to turn off this other layer and make sure this one is the active one. I'm going to just go ahead and click on a circle. Make sure you change the diameter to 6.4 millimeters. And everywhere one of these was, I'm going to just click inside of it and put my inner bolt hole. It's pretty fast. Close. We go back to my 2D view and let's make all these active. So there's all our pieces. Before I do anything else, let's go ahead and save this file. So let's save it. And CNC, I'll just call it braces. Something like that. Now let's go make some more tool paths. I'm going to turn on, I'm going to unselect that by clicking off, and I'm going to go ahead and turn on my bolt heads, turn off that first layer. I'm going to go select all these in one swoop. Then I'm going to go do what we call a pocket tool path, and I'm going to do a start depth of 0, and I want it to be the depth of my head of my bolt, which I'm going to do 3.5 millimeters. I don't want a 1/4 inch or an 1/8 inch bit. I'm going to remove this. I'm going to select, and I want that 1/4 inch down cut again. Select it, and everything looks good here. We're going to call this bolt, 12.5 millimeter diameter, inset, 1/4 bit, depth of cut 3.5 millimeters. Calculate. Now, I really would like those to be cut before this other profile toolpath. That'll minimize the chance of it putting stress on those tabs. So what we can do is we can, with that selected, go ahead and click this up arrow and we'll move it above. I'm going to now select both of these. I'm going to reset my preview, and then I'm going to preview visible toolpaths, and you can see that it cuts the insets first and then it does a profile. That looks great. And now finally we need to go get the last one. And the last one, going back to my 2D, I'll turn on all the layers, is of course the small bolt holes. Really tempting to use a 1/4 inch bit here and do it, but if you do a downcut bit, chances are it's going to overheat and it potentially could cause a fire. So I'm going to go extremely conservative. You could do a 1/4 inch upcut bit and it will probably be fine, but I'm going to go the most conservative route possible. And I'm going to go ahead and turn on just that layer. I'm going to select all of these, and I'm going to do it with an 1/8 inch bit as a pocket. And that gives me plenty of room for everything. So I'm going to do this, and I already have the inset cut. So I'm going to do a start depth of 3.5, and then I'm going to finish out the depth of my board, which is 12.1. But rather than putting a cut depth of 12.1, we've already done 3.5. I need the difference. So 12.1 minus 3.5, that means I only want to cut 8.6 down. If I put 12.1 down, it's going to be like 15 millimeters. It's going to cut into my main spoil board below, which we don't want to happen. So make sure you don't make the mistake of doing this. You could start at 0 and do 12.1 if you wanted to do it that way. It just take a little longer, and it'll be cutting air if you cut the other pocket first. I need to change out this bit, so I'm going to remove the 1/4. I'm going to select the 1/8 inch, and this will be a downcut bit as well. Select, you could do an upcut bit, that would be fine. And it's going to do quite a few passes. We could probably increase the depth that it's cutting, but I'm going to leave it as is. And I'm going to do bolt hole 6.4 millimeters. Depth of cut, I'm going to do 3.5 plus 8.6, 12.1. And then I'm going to do bit 1/8. Calculate. Let's go ahead and see these all machined out. This will start with the insets, and then it will do the profile tool path, and then it will do the 1/8 inch. The 1/8 inch is cutting such a small hole. I feel confident with as many tabs that that is not going to be a problem. But if you're worried about it, you could always cut the this inset first and then do the 1/8, and then you'd have to remount the 1/4 inch bolt and start over. So let's preview the visible tool paths. And there we go. And you have everything machined out. Let's see how long this would take. So putting these all together. It looks like to cut all that out, it'd take about an hour with your CNC. You could definitely speed this up considerably. These tool paths are much smaller, and the scale factor here is 2. It's going to machine out faster than this, probably by at least 20–30%.
I've got my square clamp on the corner, a side support, I made a few less through holes in mine that I mounted on my CNC than I modeled in the CNC software. Yours actually has more versatility because it gives you more possibilities of shifting forward and backward as far as squaring things off. And underneath each of these bolts, obviously there's a threaded insert that I put into the particle board. I put it dead center at the crosshairs of my grid lines so that I know it's perfectly aligned. So I had my CNC actually mill those threaded insert holes. When I milled them, I did 12.5 millimeter hole in width, milled down 4 millimeters for the top of my threaded insert, and then I went an additional 10 millimeters. That gives me a little extra room for the threaded insert at a diameter of a hole of 9.1 millimeters. Let me show you the beauty of what we've done. I have my square corner bracket. I have a couple side supports here, and I'm going to go ahead and just slip a board like I was going to CNC it. I'm going to press it forward, and then I know that this edge is flush, so it's parallel to my router, and then I push this way and I know it's aligned that way. And then to hold it in place, I could use the T-tracks, but I'm going to use something else. I made these little cams. This is a larger diameter one back here. This is a smaller diameter. My next video, I'm going to give you the free software that you can just cut and paste from right below my description of my video into OpenSCAD, and you can make whatever size diameter cam you want, whatever handle length you want, where the pivot point, wherever you want, and then you can cut them out on a scroll saw, a band saw, a router, your CNC. When you get all done, you're going to put threaded inserts into your table, and then once you have those threaded inserts in, you can pivot this. If it's too far away, your threaded insert, so it's not actually hitting the board, you just put a shim board in and press, and it will push pressure. And here's another cam I've got on this other side, and I'm just going to put a little shim in, and I'm going to press, and when I'm done, you can see it's got a nice hold. I could put another hold down over here if I wanted to, but that does a really nice job. The beauty is when you get all done, you just release the cam, you pull out this, and you're ready for your next board to go on. You didn't drill any holes, you didn't waste anything, your CNC. Hope that helps. Good luck with your setup. If you have any questions, just let me know.